edge is a movement.
Mm.
That's it. I mean, that's the way to look at it. Edge is not something. The internet was a movement. So the edge is the next generation of the internet.
As the speed and reliability of the internet has improved, it's become integrated into the basic functionality of our computer systems, phones, and even dishwashers and cars. But relying on massive data centers in faraway locations can slow things down. Enter the Edge Internet, a global framework that brings the servers you rely on closer to the edge of where you are. But this framework requires software solutions. This is the problem Ganesh Sundaram of AlefEdge is trying to solve. In this episode of UpTech Report, I talk with Ganesh about his efforts to create an operating system for the Edge Internet and how he believes this technology will be affecting us all in the future. Ganesh, I'm excited to be with you and learn more about AlefEdge. To start us off, I'm going to ask you to describe your company in 5 seconds. What is it?
We're a software company. We focused on a category of the internet called software-defined mobile edge, and we started this company before edge was cool.
This concept maybe has been around, but the focus wasn't until really recently. Tell me how this evolution has happened and how you got to where you are today.
From the company perspective, given my background working with in the mobility space, I used to be at Bell Labs in my previous life and had an opportunity to participate and contribute towards the inventions that made 3G, 4G, and all these technologies possible. So I saw an opportunity to be able to help carriers deal with the next generation of the internet, which is how can they take advantage of the next generation of internet on contemporary access networks without having to upgrade. That's kind of how it all started. And that is like, is there a way to optimize the network rather than optimize the application? And another way of looking at it is as the access networks and the connectivity networks have evolved from 3G to 4G to 5G, we were able to demonstrate that edge is an integral part of 5G, as we all know. So 5G needs edge, but edge doesn't need 5G.
What problem are you seeing that you're coming in to solve with AlefEdge?
The need, the why part of the edge internet has been understood, okay? But realizing the internet, what is it that we need to do and how we're going to achieve it is where software becomes a disruptive opportunity. So what is the software that is required to create a parallel connected universe, which I call as the edge internet, that coexists with the existing internet and connects where needed, okay? And the example that I'd like to give is telephony networks existed in the 70s and 80s, and then in the 90s when cellular telephony started taking off, they created a parallel universe called the public land mobile network and connected with the existing telephony network at tandem gateways, okay? So the edges got that kind of, property where you can innovate using software. And so it is that software fabric layer around connectivity, around cloud and application enablement that is needed in this parallel universe, but at the same time connect with distributed data centers in the existing internet. So we provide that software fabric to make connectivity meet computing.
So there's this underlying hardware that's in existence, but it's the concept of the software on top in order to enable this edge opportunity, edge computing that is kind of in tandem connected to 5G. Your solution then, you're targeting what, those who are managing the hardware, the mobility providers, or
no,
who is the
market
that you're going
point.
After?
So who's our customer? That's a very good point. So it depends on the type of product line we're going after. But generically speaking, our customers are going to be our enterprises who can take advantage of private edge. 5G, for example, one of the definitions of 5G is it's a giant collection of private networks which are all connected with each other. And so enterprises want to control their own destiny. They don't want to be dependent on operators, for example. and carriers to be able to satisfy their connectivity needs. And they're also very sensitive to the CapEx and OpEx. For example, a pharmaceutical company, their core competency is coming up with the next, for COVID, for example, vaccine for COVID. So their focus is not on optimizing network connectivity and making computing work at the edge, but there is a need though, right? So enterprises is one area of focus, but we can't build all the software components. So we're also opening it up as APIs so that a developer ecosystem can start to take advantage and contribute towards the edge software fabric. So developers are also a focus area.
Give me an example of how the third one is. Give me an example of the developers. What's something that could be developed that we could hook in using the API?
Very simple. Let's start with when in the connectivity layer, there's going to be a collection of heterogeneous networks. Wi-Fi is going to be there. There's a new type of spectral access band called CBRS that has come up. There could be an existing 4G system. There are emerging 5G systems, etc. And at the connectivity layer, we found a way to create a software fabric. But there are legacy issues that already exist, and each one of them have different types of legacy issues. Can we create an API layer so that the usage metrics, what goes wrong, maybe a connectivity ops layer can be built by a smart developer out there who has the domain expertise on that, so that this is a go-to-market advantage we are creating for the customer. Edge is a movement. That's it. I mean, that's the way to look at it. Edge is not something. The internet was a movement. So the edge is the next generation of the internet. So there was again, just to be cliche, there was the desktop internet, and there was the mobile internet, and now it's the edge internet. That's how I think about it.
So what do you see then for kind of the next steps that would simplify it or make it even easier for any enterprise or any organization to say, okay, I can take advantage of this next wave of computing?
Okay. So the cloud has given us a template, right? So go back 15 years ago and close your eyes and start thinking about when enterprises were adopting new applications, right? They'd put out an RFP, 17 people will come back, and there'll be an RFP defense. And then by the time the decision is made, the technology is obsolete. The cloud made it completely simple, like a whole bunch of APIs. The IT managers basically try and then buy, right? It's all an API economy right now. So we've come up with this whole concept called as an edge API, okay? So again, let me try to remind you of how the cloud got adopted. The cloud was a very web-based paradigm where web was made programmable, and companies like Salesforce and Amazon created what is known as the programmable web. They built small software modules called web services, okay, and then exposed those web services as web APIs, right? So we have invented something called as the programmable edge, not just the programmable web. Now, can we push the barriers to a distributed internet architecture? And we've come up with something called as the programmable edge with edge services and edge APIs. So that's one layer of friction that can eliminate many layers of adoption friction, both in the technology dimension as well as the business dimension.
What have you seen the changes happen over this time, and the how many more years do you see until it actually further growth and adoption happens?
Yeah. That's a very important question. I can only revisit history from the a vantage point of how we have experienced it. Given that we started at the carrier edge by working with mobile operators, the carrier edge became a thing once 5G became a thing. So it was very rewarding to find out some of the early innovations that we had put in place were actually adopted conceptually in 5G, for example, on the architectural side. is extremely rewarding for us. The second aspect of the movement is the dimension around the Microsofts of the world, Microsoft, Amazon, any one of these hypercloud companies moving towards a more distributed cloud architecture, which they call as the edge phenomenon. So Microsoft has something called Azure Edge Zones. Amazon has Outpost, Local Hub, Sidewalk, Greengrass. I mean, we just have a lot of investments that they made on the edge, okay? And then there are companies like Packet, who we partner with. In fact, I'm mentioning a bunch of these names because they're all our partners, including Microsoft. The Packet decided they were going to have the next generation of technologies for how to provide infrastructure as a service from the hardware perspective at the edge in a completely distributed manner, okay? So I consider them to have done a lot of work, which was significantly important, and the market rewarded them, and Equinix acquired them for a sensible sum of money, right? So the data center movement also took advantage of it. And then the third dimension of it is the new breed of applications that's been constantly coming up, right? So there's been a movement towards, for example, let's take gaming. Gaming has evolved from, having an Xbox in our living room and we're playing a game to the gaming controller is now in the cloud. So latency has become a major aspect of the story, okay? So the concept of gamelets was invented by Google, for example. So the market dimension of the application and then autonomous is another phenomenon, right? Autonomous cars, we're not there yet. But the movement has created new set of technologies in the application dimension. So it is the confluence of all these three dimensions, the connectivity, the application, and the compute dimension coming together that basically demanded a more distributed architecture. I think that's why it happened so rapidly in a span of 3 to 4 years, in my viewpoint. But you had a second question. How long is it going to take before it becomes a more regular phenomenon, right? And I'm saying it's happening now, meaning we've transitioned from just doing turnkey projects to offering products at scale. It's now a land grab moment right now. And so I have no doubt in my mind, and Gartner had a very interesting bell curve around this, and we've been talking to Gartner a lot about these things. Also, it turns out that the hype cycle is in the next 3 to 5 years. This is going to happen in a big way, okay? Now, only time will tell what application is going to be the priority. 4 months ago, if we had this discussion, I would never have brought up COVID-19 in our conversations, right? Now it's completely consuming our thought process. It's probably going to for the next several months. So what new business models are going to get created, but the economic underpinnings of that S-curve have actually started to take the positive side of it. We feel it, and we're in the middle of so many deals that bandwidth is a concern for us at this point from a company perspective. Good problem to try and solve, though.
Be sure to check out part 2 of my conversation with Ganesh, in which he dives deeper into the challenges of starting a movement around a technology still in its infancy. And he tells us the revelation he had when he examined how latency affects Instagram.